A very good morning. Myself, Dr. Venu, working as a professor in the Department of Civil Engineering at Institute of Aeronautical Engineering, Hyderabad. So today we are going to discuss about the course Concrete Technology. So what is concrete technology, and what are the different modules we are going to cover in this course? So that we will discuss today. Apart from that, we will discuss course outcomes as well as course objectives and little bit introduction about concrete. So just introduction about concrete technology. So what is concrete technology? What are the different materials we will use in concrete? What are those properties of those materials we will use in the concrete? What are the different special concretes? So those things we'll discuss in this course. So the course overview is the concrete is most versatile construction materials used all around the world, and the study of concrete has become indispensable to the civil engineering graduates to learn fundamental properties of fresh concrete, hardened concrete, and strength and durability. So concrete is very, very, very important in the modern life of the world. So infrastructure development, most of the infrastructure is based on concrete. So concrete technology provides a comprehensive coverage of the theoretical and practical aspects of the subject, and it includes the latest developments in the field of concrete construction. So it incorporates the latest Indian standard specifications and codes of practice for regulating the concrete construction. So the properties of the concrete and its constituent materials, the role of various admixtures in modifying these properties to suit the specific requirements and situations are also studied in this course. So the course also provides the knowledge on mixed design for producing most economical and durable concrete, and it also enables the students to acquire the knowledge on special and new generation concrete with their applications. So this is entire course overview. So we are going to study the different materials we will use in concrete and mix design. So how to design the mix, various proportions of various materials. For example, materials we will use in concrete is cement, fine aggregate, coarse aggregate, and water. So what are the mix proportions? So how much cement we need to use, how much fine aggregate we need to use, how much coarse aggregate we need to use, and what is the water, how much water we need to add to make a concrete. So this is what we are going to discuss in this entire course. And materials, that's what I told. Materials means cement, fine aggregate, coarse aggregate. What are the different properties of those materials? What are the different grades of the cement? So those things we will discuss in this course. So the course objectives, the students will try to learn. Students will try to learn the fundamental properties of construction materials, fundamental properties of construction materials such as cement, aggregates, admixtures based on laboratory and field tests for identifying the material quality. So quality is very, very important. A student has to learn what are the different qualities of these materials. So the second one, the factors influencing the workability. Factors influencing the workability and methods involved in measuring the workability of fresh concrete. And third one, the importance of water cement ratio. Importance of water cement ratio and its influence on compressive, tensile, and flexural strengths of hardened concrete. So if you change the water cement ratio, what is going to happen to the strength? Different strength, compressive strength, tensile strength, and flexural strength of hardened concrete. So this is the third course objective, and the fourth one is the concept of quality control and design of concrete mix for ensuring the quality of the concrete. Quality of the concrete is very, very, very important in the modern life. If the quality is less, means your structure is going to be, it won't take the particular loads. Okay, quality is very, very important. So these are the course objectives. So let's come to the course outcomes. So once the student is successfully completing this course, so he should be able to choose the basic physical and chemical properties of construction materials for determining the quality of concrete. And the second one, explain the workability and manufacturing process of concrete, obtaining the economical and durable concrete. And third course outcome is the inspect the impact of water cement ratio on strength and durability of the concrete by measuring its hardened strength. The course outcome 4 is apply the destructive and non-destructive tests of hardened concrete for calculating the compressive, tensile, and flexural strength. And the next one is develop the most economical and eco-friendly concrete mix based on standard methods for producing quality of the concrete. And the last one is examine the special concretes and new generation concrete for satisfying the future needs of industry in real time. So these are the course outcomes. So once the student completed this course, so he will be able to do all these things. So these are the course outcomes. So now we'll see the syllabus, module 1. So this entire concrete technology course has been divided into 5 modules. So first module is cement admixtures and aggregates. So here in this module, we are going to study the cement. What is the chemical composition of the cement? What is the hydration process? What is the setting time of the cement? And the structure of hydrated cement, the test physical properties, different grades of the cement, right? So these are things we'll study in this module about the cement. So especially we will discuss Portland cement setting time. So we have two different setting times: initial setting time and final setting time. How to calculate, how to do the experiments to find out the initial setting time and final setting time. The hydration process. What is the hydration process of the cement? So these things we'll study in this module. And the second one is admixtures. We'll discuss in this module itself. So what are the different mineral admixtures we will use in the concrete production, as well as chemical admixtures, mineral admixtures and chemical admixtures. What are the properties of those mineral admixtures and chemical admixtures? How much dosage we need to use for the mineral admixtures and chemical admixtures, and what are the effects? So if we are using mineral admixtures, what are the effects we will see in the concrete? And if you're using chemical admixture, what are the effects? Different effects. So these things we will discuss in this module. So apart from this, we'll study about the aggregates. As I told you, aggregates are two types. One is fine aggregate and coarse aggregate. So these two aggregates we will use in concrete, right? So in this aggregates, we'll have the classification of the aggregate. So fine aggregate classification and coarse aggregate classification, and the particle shape. What is the shape of fine aggregate? What is the shape of coarse aggregate? So this also the shape will affect the properties of the concrete. So texture, bond. So texture, bond. So this is also very, very important in the concrete. The strength and other mechanical properties of the aggregates, specific gravity of the aggregate, bulk density of the aggregate, the porosity, absorption, and moisture content, soundness of the aggregates, alkali aggregates, aggregate reaction, thermal properties, sieve analysis, fineness modulus, grading curves, grading of fine aggregate and coarse aggregate, and gap graded aggregates, and mixing. So these are the different properties we are going to study in this module. So especially if we are changing any of these properties in the aggregates, obviously these are going to affect in the concrete, right? So these are very, very important. So this is about module 1. So let us come to the module 2. So module 2 is a fresh concrete. Module 2 will discuss about fresh concrete. Means once you mix all the ingredients of the concrete, like cement, fine aggregate, coarse aggregate, and water, and mix it thoroughly by using mixer or hand mixing. So what are the properties of those fresh concrete? So concrete is not hardened. So concrete is fresh one. What are the properties of fresh concrete? Those things we will study in this module. So first and foremost thing is workability. Workability of fresh concrete. So factors affecting the workability. What are the different factors will affect the workability? So measurement of workability. So we have different tests to find the workability. For example, we have a slump test, we have a compaction factor test, and we have a VB consistometer test. So these are the three different tests to be conducted to know the workability of the fresh concrete. So this is about normal concrete. If you come to the special concrete, that is say SEC, self-compacting concrete. So we have V-funnel test, L-box test, U-box. So we have etc, etc. So we have different experiments, different tests to know the workability of fresh concrete. And the effect of time. So if you effect of time and temperature and workability. So if you leave the fresh concrete for 10 to 15 minutes, what is going to affect the workability? How it is going to affect the workability? So those things. So if the concrete is subjected to temperature, concrete is subjected to temperature, what is going to effect on workability? So those things we will study in this module. Segregation, bleeding. So what is segregation? What is bleeding? So mixing, and vibration of the concrete. How to do the vibration of the concrete, and which vibrator we need to use. The steps of manufacturing of concrete, quality of mixing of water. So these things we will discuss in module 1. Especially this module 2, we will discuss only fresh concrete. And the third module is about hardened concrete and its dressing. So once if you finish the concrete, so we'll cast the concrete, right? So we need to test the concrete whether we have reached the sufficient strength of the concrete or not. So because we have to use this concrete in structural members. So we need to cast the beams, we need to cast the slabs, we need to cast the columns, we need to cast the foundation. So if you cast the concrete, if you cast the beam, so beam is having a required strength or not, we need to check it. So first of all, concrete has reached the definite strength or not. So those things we will discuss in the module 3. So hardened concrete and its testing. So first of all, this here or the water cement ratio. So we'll see about Abraham's law, gel space ratio, and the nature of strength of the concrete, maturity concept, strength in tension, strength in compression, factors affecting the strength, the relation between the compressive strength and tensile strength, and the curing. So especially this entire thing is depends on water cement ratio. So we'll discuss all these things in the module 3. So after this, we'll come to the testing of hardened concrete. So compression test, how to do the compression test. So what are the size of the mold we need to use, and how to test the concrete, which machine we need to use to test the concrete. So this is compression test. Tension test, how to perform the tension test in the concrete for hardened concrete. Which mold we need to use, how to arrange the mold, how to arrange the specimen in the machine, concrete testing machine, compression testing machine. So we'll discuss in this module. So what are the factors? Factors affect the strength. Different factors affect the strength, whether it is a compressive strength, or it's a tensile strength. And flexure test. Flexure tests also we can perform, and split tensile strength of the concrete, non-destructive methods, non-destructive testing methods. So NDT, we'll call it as NDT. So we have two different methods to find the concrete quality. One is rebound hammer test, and the second one is ultrasonic pulse velocity test. So how to perform these two tests? So if you come to the rebound hammer test, so rebound hammer will give the value of compressive strength of the concrete, compressive strength of the concrete. So, and ultrasonic pulse velocity test will give the density of the concrete, how much density is there. So those things, uh, those two tests are non-destructive tests. Non-destructive tests. In the previous one, this compression test, tensile tests are destructive tests. So we'll catch the specimens specified in IS code. So we'll catch the specimen, and this specimen will keep it in the compression testing mission, and we'll apply the load. We'll apply the load gradually, and we'll see that strength, how much the strength can bear the concrete. So these things are destructive tests. So rebound hammer and ultrasonic pulse velocity tests both are non-destructive tests. We won't disturb the sample, just we'll observe the values. So these two are non-destructive testing methods of the concrete. So what are the different codal provisions provided for the non-destructive test? So what is the elasticity of the concrete, the creep and shrinkage of the concrete, how to calculate the creep, how to the shrinkage properties of the concrete, what is the modulus of elasticity, how to find the modulus of elasticity of the concrete, dynamic modulus of elasticity, and Poisson's ratio of the concrete, and factors influencing the creep. Factors influencing the creep, the relation between creep and time, nature of creep, effect of creep, so shrinkage, types of shrinkages. So these things we will discuss in module 3. So these are the properties of hardened concrete. Properties of hardened concrete. So let's come to the module 4. So module 4 is entirely on mixed design. So what are the different constituents we use in the concrete? So, for example, in the constituents of the materials means so cement, fine aggregate, coarse aggregate, and water. So, what are the different mixed proportions? Different mixed proportions. How to calculate those mixed proportions for the required strength of the concrete? Required strength of the concrete. For example, so concrete having different grades. So it starts from M20 to M60, M70, even M100 also is developed in the concrete. So M20 means the 20 Newton per mm square. The strength of the concrete after 28 days. The strength of the concrete after 28 days is 20 Newton per mm square. That is M20 concrete. So whether we have reached that 20 Newton per mm square after 28 days or not. To know this 20 Newton per mm square, so what are the different materials? Means cement. How much cement we need to add to reach the 20 Newton per mm square? How much fine aggregate we need to add? How much coarse aggregate we need to add? How much water we need to use to form the concrete mixture to achieve 20 Newton per mm square? So these things we will discuss in mixed design. So especially for the mixed design, we will use IS 10262 code. So based on that code, IS code, we have to design the mix. We have to design the mix. And we need to do so many trials whether we have achieved the strength or not. So we need to catch the samples. We need to catch the samples, and we need to test it after 28 days. So whether we have reached the particular strength or not. For example, as I told you, for M20 concrete, whether we have reached 20 Newton per mm square after 28 days or not. If we are not going to reach 20 Newton per mm square after doing a mixed design and after casting it, so we have to we have to do it once again. We have to do it. We have to change the constituents. We have to change the proportions, and we need to test it once again. So to achieve 20 Newton per mm. Once you achieve 20 Newton per mm square, then you can say that, so this mixed design, we can use it in the site. You can use it in the site. So before going to site, we have to test in the laboratory. So these things we will discuss in module 4. So that is mixed design. And module 5 is especially special concrete. So special concrete, so we have different special concrete for the different purposes, different purposes. So lightweight aggregate concrete. So here the aggregates are very light. So for example, if you want to reduce the dead weight of the structure, so we have to use lightweight aggregates to form the concrete. Lightweight aggregate to form the concrete. So if you are using a regular concrete, so you will get the dead weight will be more, right? So we have to use lightweight aggregates to form lightweight aggregate concrete, so that we can reduce the dead weight of the structure, dead weight of the entire structure. So if you are reducing the dead weight, so automatically we can reduce the reinforcements. So we'll get the very short cross section for the beams and columns. So those are the advantages. But where we need to use this lightweight aggregate concrete, only for some particular situations only we can use this lightweight aggregate concrete, right? So those things we'll discuss in the module 5. So similarly, cellular concrete, no fines concrete. So no fines concrete means, so we are not going to use a single sand particle, single particle of fine aggregate. So we are not using a single particle of a fine aggregate. So we are using only coarse aggregate and cement, and water. So this is called no fines concrete. No fines concrete. So we are not using fine aggregate here. So it is called no fines concrete or permeable concrete. So we can say it as permeable concrete. So we'll get a lot of words. So these things we will discuss in detail about the no fines concrete or permeable concrete in the special concretes. Then high density concrete. So some particular situations we have to use high density concrete. So where we need to use high density concrete, which situations we need to use in high density concrete, what are the mixed proportions of the high density concrete, those things we'll discuss. Fiber reinforced concrete. So this is one of the emerging areas in the concrete. So till now, a lot of research is going on in fiber reinforced concrete. Fiber reinforced concrete, so we have to use some fibers to improve the strength of the concrete, So we can use steel fibers to improve the strength of the concrete, or we can use plastic fibers we can use in the concrete. So because the concrete is very weak in tension, very strong in compression. Concrete is very strong in compression and very weak in tension. So if you want to improve the tensile properties of the concrete, so we have to use some fibers. So we have to introduce the fibers into the concrete. So those fibers can be steel fibers or plastic fibers. So in one side, if we are using plastic fibers, so we can use the waste plastic materials, and those waste plastic we can use it in concrete. So it will be environmental friendly concrete also. So we can some plastic waste we can consume in the concrete. So it will help to the environment. So this is about fiber reinforced concrete. And so that's what different types of fibers and factors affecting the properties of the fiber reinforced concrete. What are the applications where we need to use the fiber reinforced concrete? So then polymer concrete. So what is the polymer concrete? So till now we have used cement. So in case of polymer concrete, if you come to polymer concrete, so in polymer concrete we are not going to use cement at all. We are not going to use cement at all, right? So we are using the mineral admixtures. We are using mineral admixtures and fine aggregate and coarse aggregate and binders, polymer binders to form a concrete. So this is also called as geopolymer concrete. Geopolymer concrete. Mineral admixtures means whether fly ash, GGBS. So these are the mineral admixtures. We will use these mineral admixtures to form the concrete by using polymer binders. So we'll use two different types of polymer binders. So one is sodium silicate and one other one is sodium hydroxide. So we will mix these two, sodium silicate and sodium hydroxide, and this mixture along with this mixture we'll use the mineral admixture, whether it is a fly ash or GGBS and fine aggregate and coarse aggregate. So by mixing these four, we can form the concrete. So this concrete is called geopolymer concrete. So that's what we'll discuss, different types of polymer concretes. So what are the properties of the polymer concrete and what are the applications where we can use this polymer concrete and how to cure this. So how to curing is very, very important in the concrete. So how to cure this polymer concrete? Regular concrete we can use, right? So we can put the water, everybody can see in the outside. So they will pour the water. In the concrete to increase the hydration process to achieve the strength. So what about this geopolymer? How to geopolymer concrete? So here in geopolymer we are not going to use cement at all, right? So how to cure this? Geopolymer concrete? So those things we will discuss in this module. High performance concrete, high strength concrete. So very, very important structures. Very, very important structures means, for example, if you see Hyderabad metro rail project. So piers and permanent way are built with high strength concrete. So they have used M50 or M60 concrete to make a viaduct, to make it to build the entire metro rail project, right? So that is high strength concrete. Very, very important structures. We will use high strength concrete. So it comes to the high performance concrete. What is high performance concrete? And what is the difference between high strength concrete and high performance concrete? High strength concrete, every high strength concrete is a high performance concrete, but every high performance concrete is not a high strength concrete. So here we are enhancing the performance of the concrete in the high performance. High strength means strength. So particularly strength. High strength concrete means strength. So in that also we will increase the performance of the concrete. But in high performance concrete, so it can be a normal concrete or it can be high strength concrete. So both. So if you want to increase the performance, that is called high performance of concrete. High performance concrete. So for example, ready mix plant is there 10 kilometers away from the site. Ready mix plant is there 10 kilometers away from the site. So we have to carry the concrete from ready mix plant to the site. So the travel time. So concrete should not settle within this 10 kilometers. So we have to increase the performance of the concrete. We need to increase the workability of the concrete, right? So indirectly we are increasing the workability of the concrete. So how to increase and what are the different how to increase the performance, what are the different materials we can use to improve the performance of the concrete. So these things we'll discuss in this module. Self-consolidating concrete or self-compacting concrete. So this is also one of the major research area in the present era. So self-compacting concrete or self-consolidating concrete. So self-compacting concrete. So the concrete is itself compacting. So that is self-compacting concrete. So this concrete we will use where the concrete cannot go inside. Means the reinforcement is too much reinforcement is there. Means in that particular places where vibrator cannot go inside the reinforcement, where vibrator cannot go inside the reinforcement. In that particular places, we will use self-compacting concrete. So concrete is itself compacting, so we are not going to use any external vibrator to compact in the concrete, right? So this is self-compacting concrete. So the SIFCON, slurry infiltrated fiber concrete. So these things, slurry infiltrated fiber concrete. So this is also one of the major research area as and today. So these things we will discuss in module 5. So module 5 is for recent developments in the concrete technology, right? So these are the 5 modules we are going to cover in this entire course. So books for this course we will use the books. So first one is textbooks. We'll use MS Shetty, so very popular concrete technologist. MS Shetty, Concrete Technology by MS Shetty. So S. Chand and co-publishers. And the second one is Gambhir, ML Gambhir, Concrete Technology. He is also one of the greatest professor in concrete technology, ML Gambhir. So Tata McGraw-Hill publications. So these 2 textbooks will follow for this entire course. The reference books, so we have a lot of reference books. So first one is Neville and Brooks. So Neville and Brooks is finest books in the concrete technology. And Kumar Mehta, PK Mehta. So in the PK Mehta book, you can see microstructural properties of the concrete. Microstructural properties of the concrete, entire concrete. So this is also a very good book. So A.R. Shantakumar is also one of the greatest concrete technologists. So he wrote a book on concrete technology from Oxford University Press, New Delhi. So these are the books we can refer to complete this course. So 2 textbooks and 3 reference books. So apart from this, we have a lot of reference books. You can refer whichever is feasible to you, right? So let us see, we'll see what is the advantages of the concrete, what are the disadvantages of concrete. So before going into the modules, first we'll see what are the advantages we'll get. So if you are using concrete, what are the advantages? So advantages of the concrete. So concrete is economical. Concrete is economical in the long run as compared to the other engineering materials. So except cement, it can made from locally available materials. So the coarse aggregate and fine aggregate locally available except cement. So cement from cement plant we need to hire. So except cement, so we can form the concrete by using local material. So that is the main advantage, and this is economical one. When compared to all other materials. The second one is concrete possesses the high compressive strength. So that's what I told you. Concrete is very, very, very strong in compression. Concrete is very, very strong in compression. So it possesses high compressive strength, and the corrosive and weathering effects are minimal. Weathering effects are very, very minimal in case of concrete. So, for example, if you are using steel as a construction materials. So steel, the major disadvantage of steel is corrosion, right? Weathering effects will be there, corrosion will be there. But in case of concrete, so if you are using concrete, so concrete the corrosive and weathering effects are very, very minimal. You can say nominal. So third one is the green and newly mixed concrete can be easily handled and molded and formed into a virtually any shape or size according to the specification. The fresh concrete, once if you prepared the concrete, so fresh mixed concrete or green concrete, so we can mold into any shape. We can mold into any shape based on the specifications, or it can be a rectangular one, or it can be a circular one, or it can be any shape. We can mold the concrete, new concrete. So the formworks can be reused. So we can use the formwork in different places. So we can reuse the formwork for the similar job for the economy purpose. So these are the some advantages. So some more advantages. So it is very strong in combustion and has unlimited structural applications in combination with steel reinforcement. In combination with steel reinforcement. So the concrete, we are not going to use the concrete as a single one. So in concrete, we have to use some reinforcement to form the structural member, because the concrete will take care of compressive strength. So very strong compression. So tensile properties are very less in concrete. So that is the main disadvantage of the concrete. The tensile properties are very less, right? To acquire the tensile properties, so we have to use the steel reinforcement. We have to use the steel reinforcement. Concrete and steel have approximately equal quotient of thermal expansion. Concrete and steel both will have equal quotient of thermal expansion. Because of that reason, so we are using steel as embedded into the concrete. The fifth one, so concrete can even be sprayed and filled into the fine cracks and repairs by grunting process. So we can spray the concrete. So we can finest cracks. We can repair it by spraying by grunting process. The concrete can be pumped. Concrete can be pumped, and hence it can be laid in difficult positions also. So this concrete can be pumped. For example, if you are constructing around 34th and 40th floor, so definitely the concrete will be there at the ground. So we have to pump it. Right? So 34th and 40th floors, yes, we can pump the fresh concrete 30 to 40 floors, or even more than that. Also, we can lift the concrete. So what I mean to say, very difficult to positions also we can use the concrete. We can use the concrete. And the seventh one, it is very durable and fire resistant and requires very little maintenance. So maintenance is very less in case of concrete. Maintenance is very less in case of concrete. But in case of steel, the maintenance cost is very high. So these are the main advantages of the concrete. So apart from the advantages, we have disadvantages of the concrete also. What are those disadvantages? So let us see. So these are the some disadvantages of the concrete. So concrete has low tensile strength, and hence tensile cracks will develop very easily. So that's what I told you. The previous slides, the tensile strength of the concrete is very less when compared to compressive strength. Very less. So due to this, we will get the tensile cracks very easily. The fresh concrete shrinks on drying. Hardened concrete will expand on wetting. Right? So provision for concrete joints has to be made to avoid the development of the cracks due to drying, shrinkage, and moisture movement. So whenever we are using for example, very lengthy concrete wall. So in between, we have to provide the expansion joints. In between, we need to provide the expansion joints due to shrinkage of the concrete, drainage shrinkage, and moisture movement. So due to this, we have to provide the construction joints in between, at a particular intervals, at a particular intervals. And third one is concrete expands and contracts with the change of temperature. Yes, concrete will expand and contrast with the temperature, and the expansion joints has to be provided to avoid the formation of the cracks due to thermal movement. So we have to provide the expansion joints at a particular intervals during the construction. The concrete under sustained loading undergoes the creep. Concrete under sustained loading undergoes the creep, resulting the reduction of pre-stress in the pre-stressed concrete construction. So especially these disadvantages, the fourth one will be for pre-stressed concrete. So the concrete will sustain the loading. It undergoes the creep. It undergoes the creep. So it results the pre-stress, reduction of pre-stress. It results the reduction of pre-stress. So there is a loss will be there in the pre-stressed concrete. There is a loss will be there in the pre-stressed concrete. The fifth one, concrete is not entirely impervious. Concrete is not entirely impervious to moisture, contains soluble salts which may cause the fluorescence. So concrete is not entirely impervious. It is not impervious. It is a pervious only, right? So it will take the moisture. It will take the moisture and a soluble salt. So which cause the efflorescence in the concrete. Efflorescence in the concrete. The sixth one, concrete is liable to disintegrate by alkali and sulfur attack. So concrete is liable to disintegrate by alkali and sulfate attacks. So this will disintegrate. So for example, if it is concrete is subjected to sulfate attack, concrete is subjected to sulfate attack means the concrete will react the sulfates. Concrete will react the sulfates, and it forms some other material. So that is called ettringate. It will form the ettringate. So which will reduce the strength of the concrete. Which will reduce the strength of the concrete. So this is the main disadvantage. This is the main disadvantage of the concrete. And lack of ductility. The lack of ductility inherent in concrete as a material is disadvantageous with respect to earthquake resistant design. Yes, concrete is very disadvantageous with respect to the earthquake resistant design. But we can take some measures to form earthquake resistant design. But the major disadvantage will be there in case of concrete. So these are the main disadvantages. So concrete will have the advantages and the disadvantages. So when we compare both advantages and disadvantages, advantages will have more in concrete. So we can prefer the concrete for the construction purpose. So because of that reason, so even for the pavements also we are using concrete for the making of pavements. So especially the rigid pavements, the maintenance cost is very low. So we can use the concrete, right? So these are the major advantages and disadvantages of the concrete, right? So thank you very much for your patience. So from next class onwards, we'll start the modules. First module 1, and we'll start with the cement. So what are the different grades the cement, and what are the different tests to be conducted for the suitable for the concrete. So those things we'll discuss in the next class, right? So today especially we have discussed the entire course overview of the concrete technology. So then we have discussed what are the course objectives and course objectives and course outcomes, and what are the different modules. The entire concrete technology has been divided into 4 modules. So which module which is going to cover, so that we have discussed. And so we have discussed about what are the advantages and disadvantages of the concrete. So first of all, we need to know what are the advantages, what are the disadvantages before going to elaborately discuss on concrete technology. So thank you very much for your patience.
Like, share, and subscribe. Hit the bell icon for more updates.